So in today's video, we will discuss about the previous year's Neet question and answers from carbonyl compounds and carboxylic acids with special reference to Aldol condensation and Cannizaro reaction. So I will be discussing 12 questions and answers from Aldol condensation and Cannizaro reaction. So let us start with the first question. So Aldol condensation will not take place in the given the four options. So this question has been asked twice in the year 1999 and as well as 1996. So we know that it's a basic question. This formaldehyde, we know that formaldehyde does not have the alpha hydrogen. So formaldehyde does not have the alpha hydrogen. So Aldol condensation will not take place. So the option we can give it as C. So next question will be acetaldehyde reacts with option A, the given electrophiles only, nucleophiles, free radicals, both electrophiles and nucleophiles. So acetaldehyde reacts with, let us take the structure of acetaldehyde, CH3, CHO, or we can write it as CH3, C double bond O, CH3, C double bond O and the H. We know that because of the electronegativity, oxygen will be having the negative sign and carbon will be having the positive sign. So because carbon has got the positive sign, what happens is it is like an electrophile, because we know that electrophiles have the positive charge. On the other hand, nucleophiles will have the negative charge, like OH minus like that. So this OH minus will react with the positive carbon. So because it's an electrophile, it will react with the nucleophile, or the nucleophile can come and attack the positive center. So you can give the options nucleophiles only. So the next question will be the product formed in Aldol condensation is. So the product formed in Aldol condensation, they given the four options: beta hydroxy aldehyde or beta hydroxy ketone, alpha hydroxy aldehyde or ketone, and alpha beta unsaturated ester, beta hydroxy acid. So in Aldol condensation, we know the product will be like when you take the acetaldehyde, CH3CHO. So we know that CH3, C double bond O, H double bond aldehyde, and when you treat with the base, we know that generation of the carbanion will take place. So one H will come out as water molecule. So we will be having the CH2 minus, C double bond O and the H. This will be the first step in the Aldol condensation. You know that it's the carbanion, generation of carbanion. So this we will add with the aldehyde. So CH3, C double bond O H, and electronegativity it is minus and this is plus. So we know that this gets added here. So what will be the product now? It will be CH3, C, here it will be CH2, CHO, and here we will be having the O minus, or in case after protonation it will be OH. So after protonation it will be OH. So it will be CH3, C, OH and the CH2, OH, and it will be on the H here. So we know that this carbon is a functional group, aldehyde is a functional group. So this will be the alpha carbon, this will be the beta carbon. Same case, CHO will be the functional group, this carbon will be alpha, this will be beta. So to the beta position, OH group is attached, beta hydroxy. So the answer will be beta hydroxy. Answer will be beta hydroxy aldehyde or beta hydroxy ketone will be the answer. So next question will be a strong base can abstract an alpha hydrogen from. So we know that in general this ketone CH3, C double bond O, CH3, when it's treated with a base, it will pull a nitrogen oxide. So we'll get the CH2 minus C double bond O and the CH3. So directly you can give the option A for ketone. Even in alkane, amine and alkene, they are also it can be removed. The base can abstract the alpha hydrogen from there. But what happens there is, see, in case of ketone, in case of alkene and the amine, in all three, they are like electron releasing groups. They are electron releasing groups. So they will release the electrons. So what I want to mention here is, in case of, let me take the structure now. Written CH2 minus, the C double bond O, CH3. Here oxygen is electronegative, so minus, carbon is positive. So what happens is, any compound which is having, like here you can see the entire species, it is like an carbonyl, so it has got negative charge. So greater the negative charge, so greater the charge, either negative or positive charge, lesser will be the stability. Lesser will be the stability. So what happens in this case, even though you got the negative charge here, this carbon CO, the carbonyl group, CO group, what happens is, it is having the plus, it will try to pull some electrons from here, thus decreasing the charge. So this compound will be more stable. But in case of alkane and amine, to the same negative part, what they do is they will supply the electrons there. So still the negative charge will be more. So the compound will be less stable, and that's the reason we are given the option as ketone. So please understand, greater the charge, lesser will be the stability. Here actually the charge is minimized because carbon is having the positive charge. It will reduce some of the minus charge here. So what happens, greater the positive charge, lesser will be the stability. Once the charge gets decreased, then the compound will be more stable, and this can happen only in case of ketone. Because here they withdraw, but on all these cases, already negative sign is there in these cases, and they will also supply negative, making the charge more. So compound will be less stable. So that's why we are not giving alkane, amine, or the alkane. So answer will be ketone. So the answer will be ketone. So next question will be, which of the following compounds will undergo self-Aldol condensation in the presence of cold alkali? So we know that very easily we can make it, because CH3, CH2, C double bond O, H. Here we got that alpha carbon as well as the alpha hydrogen. Okay, that too please remember, when two things are there, like when alpha hydrogen is present in two cases, two options. See, in this case, alpha hydrogen absent. In this case, alpha hydrogen is absent. Benzoate also alpha hydrogen is absent. Here alpha hydrogen is present. Here alpha hydrogen is present, and here also it is present. Because even there we can write CH2 double bond. Maybe you can write CH. CH2 you can write less C double bond O and the H. So here also alpha carbon is present, alpha hydrogen is present. Here also present, but prefer where there are two hydrogens. Where there are two hydrogens, then only what happens is the water molecule will come out. Minus H2, water molecule will come out in the final product. So you can prefer this. So this H2 will react with oxygen of the other aldehyde. So water molecule will be eliminated. So you can give the answer option D. So next question, of the following, which is the product formed when cyclohexanone undergoes Aldol condensation? So they given that four options. The moment you see these structures, it will be a little bit scary, but no need to worry about that. So forget these four structures. Let us take cyclohexanone, because the question is asking, of the following, which is the product formed when cyclohexanone undergoes Aldol condensation? So let me take the cyclohexanone. Before that, we know cyclohexane. So cyclohexane will be the same benzene ring without the thing. All will be like, we can tell in each and every part we will be having the CH2. So this will be the cyclohexanone. So this is cyclohexane. from the cyclohexane, remove 2 hydrogens because each and every point has got 2 hydrogens. And we know carbon, like CH2, I can write like this. So what we can do is remove this hydrogen and replace by an oxygen. Valence will be like this. So here I will write double bond O. The same thing remaining to be same, CH2, 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 CH2 and CH2. In this place, instead of that, I am going to remove the H2, replace by oxygen. And because the moment I replace oxygen, you know valency part is there, because carbon is losing both hydrogens. So we write the C2 bond O. So this is the cyclohexanol structure. This will be the structure. Now because this part I told you, it is C double bond O. This is the functional group. So here also naturally we got the CH2, this point. Here also we got the CH2. So alpha carbon present, alpha carbon present, alpha hydrogen present, alpha hydrogen present. It will undergo Aldol condensation. So let me take this. I will write the cyclohexanol like this. I will write one cyclohexanol like double bond O. Then I will take one more cyclohexanol. Like double bond O. Now we know that each point has got a CH2. So what happens? Elimination of water molecule will take place. For any final product, from the alpha hydrogen, remove the 2 hydrogens, and from the other aldehyde, remove the oxygen. For any final product, what I'm telling is, repeatedly I'm telling, it's a small trick also you can take like that. Remove the hydrogens from the alpha carbon and remove this oxygen. So minus H2 will be there. Then what will be there in the structure now? Of course, this will be the structure there. Double bond O is no more there. But carbon is there. Only carbon is there. Carbon valence is 1 and 2. So naturally you need a double bond here. Remove point. Because it was C double bond O, now the oxygen has been removed. So only carbon is remaining. Carbon, it's attached with this carbon and this carbon. So still valency 4. And here also same thing. This carbon goes into 2 hydrogens. So I can make the structure like this. So this point. And maybe the double bond O I can write here. Because it has to be from the alpha, no? So C double bond and you can join like this. And you can see the first option. So it will match with the option A. So the next question will be the major product of the following reaction is. It is Neet 2019 question. So they given the structure. This is phthalic acid with ammonia. They given the 4 options. So now let us take that reaction there. So benzene ring. When I write 1 COOH, we call it as benzoic acid. When I write 2 COOH, it will be phthalic acid. So you are treating with ammonia. So what happens in this case? I will write the product here. So OH and then H from here will come out as water molecule. So we will be taking 2 molecules of ammonia in this case. So what will be remaining there? We will be having a CO, correct na? CO. OH and 1H will go, so NH2 will be there. Here same thing will happen here. CO, NH2. Now this one heating they are given. So what happens is we got the NH2 and NH2. So 1 ammonia, 1 NH3 and H, so minus NH3. Ammonia will come out. So what will be present there? It will be CO. You also see NH2 and so CO will be there in both cases. Carbon and here only 1 nitrogen will be remaining and 1 hydrogen will be remaining. Because totally 2 nitrogens, 1 has gone as ammonia, so 1 is remaining. 3 hydrogens gone, 2 plus 2, 4, 1 will be remaining. So this is the thiamide. And that you can see. So this is C double bond. Option will be the C option. So next question, which one of the following on treatment with 50% aqueous sodium hydroxide yields the corresponding alcohol and acid? So I think in Cannizaro reaction we discussed a lot this morning. So basically we know that one will undergo oxidation, the other will undergo reduction. So it will be the Cannizaro reaction. And for Cannizaro reaction, the compounds which do not have alpha hydrogen, it will be the benzaldehyde. So we know that whenever we get that 50% NaOH or KOH, and when the product is an acid and an alcohol, it will be always Cannizaro reaction. So acid and an alcohol, and the acid will be in the form of the ions CO minus. So this alcohol acid 50%, it always refers to Cannizaro reaction. And we know about these compounds, all B, C, D. In all cases, we got alpha hydrogen. But Cannizaro reaction will take place only where there is alpha hydrogen is absent. So only in this case, alpha hydrogen is absent. Alpha hydrogen is absent. So it's understood the remaining three will undergo Aldol condensation. So the option will be A. So next question, when metachlorobenzaldehyde is treated with 50% KOH. So last question we discussed 50% KOH. Once again, it's a Cannizaro reaction. The product will be an acid and an alcohol. So let us see the structure of chlorobenzaldehyde. First, you guys are aware of benzaldehyde. So I write like this. Maybe if I write CHO, this is the benzaldehyde. So the first portion will be ortho. The first portion will be, we call it as ortho portion. The second portion we call it as the meta portion. So when metachloro, so Cl. So I write the Cl in this case. So by default, we know that in Cannizaro reaction, one will be the acid, second will be the alcohol. No changes in this chlorine part. So here ortho, meta. Here also ortho, meta. So the immediate portion will be ortho, next will be meta, and this will be para. So here also ortho, meta. So probably this one should be the answer. Option will be B. So next question, predict the products in the given reaction. Once again 50% KOH. I think the same question they have asked in a different way, because it's also like ortho, metachlorobenzaldehyde. So it's a combination of alcohol and an acid. So but please remember, you got the Cl here na. So they given Cl, CH2OH, CH2CO minus, later they given the options. So we know that one will be the alcohol and second will be the acid. So we can go with option C, because we know that it is C6H5 CHO. What happens is you add that hydrogen here, so you get what? C6H5 CH2OH. So CH2OH will be the alcohol in this case, because in Cannizaro we know that in one case we are adding the hydrogen and second will be the iron part. So the option will be C. So next question, which of the following reactions will not result in the formation of carbon-carbon bonds? So you can directly make the Cannizaro reaction here, because in case of Cannizaro reaction we know that actually if you take two compounds like a benzaldehyde and a benzaldehyde, there is no addition between the carbon and carbon, or getting it. So you'll get two separate products. One will be the alcohol and one will be the acid. So actually what is not taking place here? The carbon-carbon bonds are not taking place here. So between any carbon of this aldehyde and any carbon of this aldehyde, they are not going to join together. So they are independent. So you can give the option Cannizaro reaction in this case. So next question, which one of the following esters cannot undergo glycine self-condensation? So probably I think check for the alpha hydrogen. So in all these places, when you take this, you got that CH2, C double bond O, C2H5, the very first structure. Second structure will be C double bond O, C2H5, and here we got the C6H5. So I think in this case, alpha carbon is present, but alpha hydrogen is absent. So alpha hydrogen is absent. The second option. Remaining you got the alpha hydrogens, alpha carbon, alpha hydrogens. Here also it is present. Here also it is present. So how to make us, just take the COO, make a C double bond O in one side, and second side you got a CH2. Get my point? So this will be OC2H5. So when you take this functional group, alpha carbon, alpha hydrogen. Here also alpha carbon, alpha hydrogen is present. Here also alpha carbon. So alpha hydrogen is absent only in the second option. So this will not undergo glycine self-condensation. Repeatedly, I am telling you that glycine schematic is somewhat similar to Aldol condensation only. So the option will be B.